I'd like to talk about my undergraduate thesis, which obviously gave me the toughest time among all my research work. The goal was to create a linear algorithm for the conjugacy problem in Thompson's group F. I chose this project to work on abstract math problems and algorithm design, areas which I felt I needed to improve upon. And it looked like a hard problem. It involved topological graph theory, and Thompson's groups are infinite groups, so I was working with graphs that could be infinitely long. These graphs are called strand diagrams, which are complicated graphs embedded on the annulus. And in order to check whether two strand diagrams are conjugate, I needed to reduce them and then find out whether the reduced graphs were the same. The research was going good. I made fast progress in the first couple of months, then I was completely stuck. The problem was this. Reducing sometimes resulted in multiple connected components, and I wasn't finding a way to keep track of these components that would allow me to compare them using a linear algorithm. I tried keeping track of the faces of the graphs, the ordering of the edges around vertices, but none of them led to a linear solution. After almost a month of hard work, I found a lead. I defined the cutting path, which was a path from the inside of the annulus to the outside, and it hits the edges of the graphs in concentric order, hitting the innermost edge first and the outermost edge last. This eventually identified the concentric ordering of the components using a very simple way, leading to a linear solution. I also wrote programs for drawing strand diagrams. I released Java implementations as jar file, source code, and Java applet on the internet, and quite a big write-up. You can see my paper in my website.